Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. In the previous year, I thought it will complete in one video. So it went until 6 parts. CBSE Grade 10 Physics, all chapters. Still we are doing. Still we are doing. So maybe. So I'm expecting this is the last part. This is the last part. Okay. Now, in the previous video, we discussed until electric current, CBSE Grade 10 Physics, heating effect of electric current. So all those points we discussed. Now, we will discuss about magnetic effects of electric current. So heating effect of electric current already completed. So V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T, P equal to VI. Everything is completed. Now we will discuss about magnetic effects of electric current. Magnetic effects of So I already started the test series. So you can check in the community post. So I started the test series CBSE Grade 10 Physics. CBSE Grade 10 Physics. Okay. So whatever are topics, whatever the chapters I'm explaining, on the chapters, questions. So we need to practice, right? So we have to practice how they will ask in the exam, what type of questions they will ask, and each question how many marks it carries, and how to attempt and all those things. Okay. So like a test series, daily test series I'm conducting. So maximum daily one test I'll post. You can follow the community post. And for grade 11 and grade 12 also related to particular topic. So MCQs I'll post. You can answer those questions. Anyway, topics discussing here. Okay. Question and answers and like a test series. Notes I'll try to upload the notes. Okay. Those who need the notes, you can let me know. So those who need the notes, class notes, those who need the class notes. Okay. So whatever topics I'm explaining in that, if you have any doubts, my Instagram page is there. So you can check my Instagram page in the description below. Okay, I given my Instagram page. So you can no, send a message if you have any doubts. If you have any doubts, you can send a message. I'll try to look into that. So if possible, I will give the relevant answer to your questions. Okay. Or if not in the class, at least I will tell if it is a common question from everyone, like particular topics, so particular concept need to be explained are related to that one, you can post the questions, and in a community post you can post the questions like that. If any questions are there, you can let me know. Definitely I'll look into that. So my Instagram page is there. So those who have any doubts, you can go and watch my all videos, YouTube channel. So many videos are there related to physics content. Okay, so nearly 4,000 plus videos are available related to physics. So here, what are the MCQs? What are the MCQs? Short videos I posted. Yeah, so if I mention JE physics like this means, so those are foundation questions. Okay, foundation questions. Okay, so sir, these questions won't come in the mains or advanced. Yeah, I agree. I accept. Those are short videos. Those are fundamental videos. Okay, so foundation topics. like a SI unit and physical quantities, and yeah, like which quantity it is, scalar or vector, like that. Questions I posted, the short videos I posted. You can check the neat problems videos are there in playlist, neat problems. And okay, and one more thing, light reflection diffraction chapter complete videos are there. And anyway, remaining chapters like human eye and colorful world, human eye and colorful world, electricity, magnetic effects of electric current, those videos are also available. You can check in the playlist. Now I'm explaining about magnetic effects of electric current. Related to magnetic effects of electric current also videos I posted, so you can check once. Magnetic effects of electric current. Magnetic effects of electric current. Electric current. Magnetic effects of electric current. Okay. So related to magnetic effects of electric current, we can observe here. So I'm considering the cell here. So this is the cell. Switch. Conductor here. Ammeter. So rheostat. Here is the rheostat. Rheostat. So here is the thick copper wire. So I'm taking this thick copper wire. Thick copper wire. Thick copper wire I'm considering here. Current is passing through it. Current is passing through it. So we'll discuss one by one. One by one. So 2 points related to this one. I'll explain in depth related to concepts. Okay. So current is passing like this. Okay. And measuring ammeter. If I place ammeter here, I'm placing ammeter here. Okay. So current is passing like. Now you can observe one thing. Now you can observe one thing. If the current is passing through this one, the current is carrying that. So magnetic effects of electric current. The meaning of the statement is, the meaning of the chapter name is magnetic effects of electric current. So by passing the electric current through the conductor, so it produce magnetic field or it act as a magnet. Okay, it behaves as a magnet, right? So temporary magnet. It is a temporary magnet. So whenever you remove the battery, it won't act as a magnet. If you attach the magnet, if you attach the battery, it will act as a magnet. Okay, so this thick copper wire or conductor, if you are considering. Okay, now around it, the magnetic field will be produced. Around the magnetic field will be produced. How can you identify this magnetic field? How can you identify the magnetic field? By using compass. By using compass. Yes. Compass is a Okay, so compass consists a small magnetic needle present inside of it. So if you're taking compass like this, a small magnetic needle present inside of it, so it always shows north and south, north, south and east and west, east and west. Okay, so listen carefully. It always shows north and south direction. Exactly, it won't show perpendicular direction like this. So it will show somewhat tilted. Okay. So by placing the compass, we can observe the magnetic field around the conductor. Around the conductor. So the magnetic field will be around the conductor in the form of concentric circles. Concentric circles, if you are taking here, so around it, so like this it will be there. So concentric circles. What is the meaning of this? Okay, concentric circles. What is the meaning of the concentric circles? Because so taking as a center of the rod, so around it the magnetic field will be formed. Around it magnetic field will be formed. So that those are called concentric circles. If more rings are there, more concentric circles are there near to the conductor, more magnetic field will be there. So if it is far, if it is when you keep on moving, okay, so the magnetic field reduces. So near to the conductor, the magnetic field will be more. Here, if I am taking near to the conductor, the magnetic field will be more. So as you move away from the conductor, the magnetic field will be less. As you move away from the conductor, the magnetic field will be less. Yes or no? Why? So near to the conductor, this magnetic field will be more. As you move away from the conductor, magnetic field will be less. So it depends on the length of the conductor. So it depends on the distance from the conductor. Distance from the conductor. Okay. So if you are placing here, so magnetic field will be there. If you are moving away from it, okay, so near to the conductor, the more magnetic field will be there. As you move away from the conductor, magnetic will be less. Magnetic field will be less. Yes, right? Yeah. Here, so now you can observe 2 points I'll explain. First point number one is if the current is passing through the conductor, it acts as a magnet. Okay, it behaves as a magnet. So it produces magnetic field around it. It acts as a magnet. So magnet. Second point is, so as you move away from the conductor, the magnetic field will be less. As you move near to the conductor, the magnetic field will be more. Okay, so more near to the conductor, near or far? Near and far. So near to the conductor, magnet will be more. Away from the conductor, magnet will be less. So how can we identify the magnetic field? By using compass. Okay, so by using compass. Compass is a small magnetic needle present inside of it. So a small magnetic needle will be there inside of the compass. Okay, so it is also a magnet. It is also a magnet. Okay, so it is also a magnet, right? Next, fourth one. So here we can magnetize whenever we want. So we can demagnetize also. If you remove the battery, so it won't act as a magnet. So the conductor won't act as a magnet. If you attach the battery, it acts as a magnet. If you attach the battery, it acts as a magnet. So the thick copper wire, okay, thick copper wire. So it acts as a magnet. If you remove the battery, it won't act as a magnet, right? Yes. Now, so that is uh, magnetize, demagnetize, attaching the battery and removing the battery. Like you can say magnetize, demagnetize, magnetize. So demagnetize and magnetize whenever we want to magnetize. So we can attach the battery. Whenever we don't want, we can remove the battery. So by doing that one, we can understand. Okay. So it is the electromagnet by current. If the current is passing through the conductor, it acts as a magnet, right? And one more point, if you change the direction of the current, fifth point is very, very important. So one more question will come related to this one, related to fifth point. So related to all these points, questions will come, but fifth one is very, very important. The last one is very important. What is the last one? That is If you change the current direction, so normally if the you can see current is moving downward direction like this, current is moving downward direction. Okay, magnetic field will be produced. Magnetic field will be produced. So how the magnetic field will be produced? By using right hand thumb rule. By using right hand thumb rule. Okay, so right hand thumb rule. So if the current is moving downward direction, if you wrap the fingers, this is my right hand. So right hand thumb. So if you placing the thumb along the current direction, curly finger shows the magnetic field direction. Curly finger shows the magnetic field direction. So here if the current is moving downward direction, so the compass should show towards east direction, deflection. The compass shows deflection towards east direction. Here you can see east direction. If the current is moving upward direction, magnetic field will be anti-clockwise. So we can take clockwise direction and anti-clockwise direction. So if the current is moving downward direction, so the magnetic field will be clockwise. So downward direction, magnetic field will be clockwise direction. This is a clockwise direction. If the current is moving upward direction, the magnetic field will be anti-clockwise direction. Anti-clockwise direction. So very, very important. So clockwise direction is south pole, anti-clockwise direction is north pole. So related to clock phase rule, if the current is moving, if the current, so that is different. First you can check it once. Okay, so if I say all the things at a time, it may be getting confused. So until here it is clear. Just check once. First point is, when the current is passing through the conductor, it acts as a magnet. That is electromagnet. Point number one. Point number two. So near to the conductor, magnetic field will be more. Near to the conductor, magnetic field will be more. As you move away from the conductor, magnetic will be less. Third point, how can you identify the magnetic field? By using compass. If you place the compass, it shows the deflection. So if you place near to the conductor, more magnetic field will be there. If you place away from the conductor, it will be less magnetic field. So magnetize and demagnetize. When you attach the battery, it acts as a magnet. If you remove the battery, so it won't act as a magnet. And last fifth one, as I said, fifth one is very important. Direction. Direction is very important. Direction of magnetic field. So if you change the battery, so initially if you attach the battery, current is flowing so downward where going. So here when the current is passing in the inside of the conductor, that time current is moving downward direction. Yes or no? Current is moving downward direction, magnetic field will be clockwise direction. If you change the current direction, current is moving upward direction. How can you change the current direction? By changing the polarities of the battery. So initially, so positive terminal is up. Now later if you change like this, current will move downward direction. Then magnetic field will be like so here in this here upward direction. In the conductor we have to think. In the conductor current is moving upward direction. Upward direction means anti-clockwise. So here you can observe current is moving downward direction. Magnetic field will be clockwise by using right hand thumb rule. By using right hand thumb rule, we can identify if the current is moving upward direction. So magnetic field will be clockwise or anti-clockwise. Current is moving up here. If you take this side, okay, current is moving downward direction. So magnetic field is clockwise direction. Current is moving upward direction. Magnetic field is anti-clockwise direction. Simple, very simple. So take the thumb. So along the current direction, if you will place the thumb and the curly fingers, folding fingers in which direction it's representing, that you have to understand. Okay. So current is moving upward direction. Yes. So like if you take this one, if current is moving downward direction, then clockwise direction. If you take this one, current is moving upward direction, anti-clockwise direction. So by changing the polarities of the battery, so magnetic field also changes. Understood or not? Very clear? Yes or no? If you change the polarities of the battery, magnetic field direction also changes. That is what I am going to say. Okay, that is what I am trying to say till now. The point is, if you change the polarities of the battery, polarities means positive terminal, negative terminal. Okay, if you interchange the battery, so initially current is moving like this, downward direction. Later the current is moving upward direction. So here initially the current is moving downward direction, the magnetic field is clockwise. Here you can see clockwise. So later if I change the battery, current is moving upward direction. So magnetic field is anti-clockwise direction. Anti-clockwise direction. That's enough. So we can understand one thing. If you change the polarities of the battery, if or simply we can say if you change the current direction, if you change the current direction, magnetic field direction also changes. That's simple. Very, very simple. Very, very easy. If you change the current direction, magnetic field direction also changes. Magnetic field direction also changes. These 5 points are very, very important, highly important. Okay, so make sure that you are remembering all these 5 points. Point number one, if you add the battery, it acts as a magnet. Near to the conductor, magnet will be more. Away from the conductor, magnet will be less. So, how can we identify? By using compass. If you place compass, deflection will be shown. We can identify the current, no magnetic field is created. Magnetic field is there around the conductor. So, if you attach the battery, it acts as magnet. If you remove the battery, it won't attack. It won't act as a magnet. Coming to the direction, if you change the polarities of the battery, magnetic field direction also changes. Magnetic field direction also changes. That is the concept. Okay, that is very, very important concept. Okay, these 5 points I am trying to convey to you all. Right? Yes. Next one. So by using right hand thumb rule, very, very important. By using right hand thumb rule, we can identify the magnetic field direction. So thumb shows along the current direction. Thumb shows along the current direction. So curly finger shows the magnetic field. Curly finger shows the magnetic field direction. So thumb shows the current direction. Curly finger shows the magnetic field direction. Okay. So if you take the conductor, so current is passing like this, curly fingers like this. Okay. So we can take. If you take current is reverse, so current in this direction, curly fingers. In which direction curly finger showing? Okay, along that direction the magnetic field will be there. Right? I hope it is very clear. So till now, so related to the concept, that is magnetic effects of electric current, related to the heading only, I explain entire concept related by taking the heading that is only chapter name, magnetic effects of electric current. By taking the chapter name only, I explain everything. Current is passing to the conductor, it acts as a magnet. So magnetic field will be more near to the conductor. So the magnetic field will be in the form of concentric circle. Magnetic field will be in the form of concentric circle. So rod act as a conductor. So taking this rod as a center, so around it a magnetic field will be there. So in the form of magnetic field lines. Magnetic field lines. Okay, now we will discuss about what exactly the magnet. So till now we discussed magnet. So it produce magnetic field lines will be there, concentric rings will be there. Near to the conductor, magnetic field will be more. Away from the conductor, magnetic field will be less. Like that we discussed so many points related to magnet. So what is a magnetic field? So what are the magnetic field lines? How it will behave? So we will discuss all those points now, right? Okay, so magnet is nothing but the substance which attract the magnetic materials. The substance which it is a property of attracting or repelling. So the substance which have property of attracting or repelling. So that is called magnet. So magnet has two poles. Or natural magnet is there, artificial magnet is there. There are two types of magnets, artificial magnet and natural magnet. Natural magnet is magnetite. Magnetite is a natural magnet which occurs from earth crust. Natural magnet is occurs from earth crust. Magnetite is the natural magnet. Magnetite is the natural magnet which occurs from earth crust. Okay, magnetite. Okay, which comes from magnesia. And Artificial magnet, man-made magnet, according to our requirement, according to our requirement. So we made according to our suitable conditions. So those are called man-made magnets or artificial magnets. Artificial magnets are U-shaped magnet, dumbbell-shaped magnet, like a cylindrical magnet. Like there are many of. So today, purely we'll discuss about bar magnet. Related to bar magnet, I will discuss. So what is magnet, like that? How it will be? What are the properties of magnet? Everything. So I'm taking here. This is a bar magnet. Bar magnet. Okay. So here North Pole and South Pole. Point number one: poles. Magnet have two poles. Magnet has two poles. North pole and south pole. Both poles have equal strength. Both poles have equal strength. So north pole and south pole, both poles have equal strength. Second point is, so those two poles are not exactly at the end, so they are little inside. If you drop the magnet, into the sand, okay, so what happens? So the magnetic materials will attract at the ends, those at the poles of the magnet, than in the middle. Okay, so attracting will be more at the poles, than in the middle. Okay, so at the poles, as I said, magnet has two poles, north pole and south pole. Magnet has equal strength. Poles have equal. Magnetic poles have equal strength. North and south has equal strength. If you break the magnet, still magnet has two poles. That is, those are north pole and south pole. So magnetic poles will attract. Okay, so poles have equal strength, it attract the magnetic materials than in the middle. Okay, so compared to the middle, so at the poles, attracting property will be more, and repelling also it will be. And coming to the third one, so around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. So okay, so first we'll discuss point number one. Poles. Two poles. So two poles, I'll write two poles. Two poles. Second one, and attracting, and coming to the third one. So magnetic field. So third one is magnetic field. Magnetic field. Here around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. The magnetic field. Okay. So around the magnet, magnetic field will be there. The region around the magnet, in which magnetic force exerts. The region around the magnet in which magnetic force exerts is called magnetic field. The region around the space around the magnet in which it influence felt. So we can take any definition. So final definition is, final one is, around the magnet, magnetic force exerts. That's enough. You can write. So the region around the magnet in which magnetic force exerts, or the space around the magnet in which its influence felt. It's in the sense magnet. Okay. So the magnetic field will be around the magnet. Okay. Will be in the form of field lines. So sir, you said the magnetic field will be there around the magnet. How it will be? In the form of field lines. And one more thing, and this is a magnet. Suppose if you take this is a magnet and this is magnet, until certain range only it will attract. If you take beyond the point, it won't attract. Until certain range only, until certain distance only, the magnet will attract another magnet. So if you take beyond the point, it won't attract. So until certain range only, that's why I said the space around the magnet. So around the magnet, the space around the magnet in which, so its force and its influence felt. Okay, that is called magnetic field. The space around the magnet. Okay, or around the magnet in which the magnetic force exerts. Right? Yes. Now you can see here. North and south I'm taking. The magnetic field will be in the form of magnetic field lines. Magnetic field will be in the form of field lines. Okay, so I already said you can take, so you can take five lines, 5 lines, 7 lines, 9 lines. Okay, so this is the preferable number. Preferable number. Any number you can pick and draw. So here I'm drawing 9 lines I'm taking. So one. So middle one you have to draw. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So above 3, 4 you have to draw, and below 4 you have to draw. Okay, so then you can join 1. So 3 you can join, above you can join 3, and below also you can join 3. Below also you can join 3, and here also I am joining 3. And here also I am joining 3. Okay, above 3, below 3, and middle you have to take 3 like this. So if you draw like this, it's good. Okay, 3 above, 3 below, 3 middle. So then it looks like a neat diagram, clear diagram, proper diagram. So I'm picking 9 number. Okay, so and the magnetic field. So in fourth point is field lines, field lines, field lines, field lines. Okay, 4 points. Simple, very easy. Field lines, field lines. Okay. How can you identify the magnetic field direction? Magnetic field direction. Normally, if you're taking the compass here, sorry, magnet North Pole and South Pole, if you place the compass at one position, it will show. And mark it this position and place one more position where it shows. Again, mark the position. Again, one more position. Mark, because this is north, this is south, right? South, north will attract. So north, south will attract. So if you joining this one, it will shows the free north pole direction. Free north pole direction. Each and every time you have to change the position in order that. So previous position should be attached to the next one, and this position will attach to this one, like that. If you keep on changing the position, then each time you are changing, each time while you are changing, you have to mark those positions. You have to mark those positions. After marking, so you can join that position, then you'll get the magnetic field direction. Okay, a free north pole direction. So compass you have to change. Compass position you have to change each and every time. Compass position you have to change each and every time. So here I am taking now direction from north pole to south pole. So magnetic field lines. Field lines are very important. Properties of the field lines. Properties of the field lines. Now we are discussing properties of the field lines. So magnetic field lines emerge out from north, emerge out from north, emerge out from north, and merge at south pole, emerge at north and merge at south pole, merge at south pole. Here it is merging like this. Okay, so here emerging out, emerging out, emerging out. So here you have to take the direction exactly at the line. So all the direction you have to draw in the single line. Here also make sure that, and here also make sure that. Then it looks very good diagram, right? So magnetic field lines emerge out from north and merge at south pole. These are closed loops. Point number 1, magnetic field lines emerge at north pole and merge at south pole. These field lines are closed loops. These field lines never intersect. If it is intersect, so what happens? If it is intersect, so compass should show at a time two directions where it is not possible. Compass should show at a time two directions where it is not possible. Where it is not possible. Okay. Point number 1, magnetic field lines emerge at north and merge at south pole. And point number 2, those are closed loops. These are closed loops. Outside the magnetic field direction from north to south, inside south to north. Once again, outside of the bar magnetic field will be from north to south. Inside of the bar magnetic field from south to north, south to north. And coming to the next one, magnetic field lines never intersect. Magnetic field lines never intersect. If it is intersect, so at a time compass should show two directions where it is not possible. Where it is not possible. I hope it is very clear. So these are the magnetic field lines. Properties of magnetic field lines. Property of magnetic field lines. Right? Yes. And now. Right hand thumb rule already explained how to identify the magnetic field direction by using right hand thumb rule. Okay. So next one. We will discuss current carrying conductor. Straight wire also same thing only. Previously explained that concept only. And next one, we can go to the loop. Loop. Positive terminal, negative terminal, current is flowing like this. Current is flowing. Okay, so you can observe here. So the magnetic field will be here. So, and you keep on, if you are increasing that field lines, in middle exactly it will be there like this. So this is north and this one is south, north and south. Okay, so now you can observe one thing. By using right hand thumb rule, we can identify the magnetic field direction. By using right hand thumb rule, we can identify the magnetic field direction. So it will be out. So magnetic field will be outside. Like this, it will go inside. It will be inside. Okay, understood or not? Sarah, I have one doubt. That is, so in the loop, where magnetic field will be maximum? So at the circumference or at the center? Actually, I will tell one thing. Here, when the current is passing, magnetic field will be produced around the current carrying conductor. Okay. So magnetic field will be produced. When you are keep on moving towards the center, so the lines will become parallel. The lines will become parallel. So what happens? So this magnetic field will be added to next one. This magnetic field will be added to next one. This magnetic field will be added to next one. So then one magnetic field will be added to another one. One magnetic field will be added to another one. So in the middle one, uniform magnetic field will be produced. Uniform magnetic field will be produced. So the magnetic field will be more at the center than at the edges. So than at the edges, magnetic field will be more at the center. Okay, uniform magnetic field will be produced. Uniform magnetic field will be produced because so here the lines will become parallel. So parallel to each other, So one magnetic field will be added to another magnetic field. One magnetic field will be added to another magnetic field. That's why the magnetic field will be uniform. The more magnetic field will be at the center than at the circumference. So they will ask one question related to this loop concept. That is, where magnetic field will be more, at the circumference or at the center? At the circumference or the center. So magnetic field will be more at the center than at the circumference, right? And the next one. Solenoid. Solenoid is nothing but taking the, so take straight wire and wrap in the form of cylindrical shape. Take the straight wire, so wrap in the form of cylindrical shape. So here I'm taking like this. Okay, so current is passing. Current is passing. Now the magnetic field, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 you can take. 1, 2, 3, and 1, 2, and 3. Okay, so whenever the current is moving to that side, we can take that is south. When the current is leaving, that is north. Okay, now. So here south, reaching. And here leaving. Okay, solenoid. You can observe current is passing like this. So it acts as same like bar magnet. So the properties, everything, you take the bar magnet like this. North pole and south pole magnetic field will be there. Okay, so magnetic field will be here. Okay, like this. You can observe here. So same how the bar magnet act like a magnetic field. So around solenoid also magnetic field will be there. Around solenoid also magnetic field will be there. Okay. And next point is here strength cannot be comparison between bar magnet and solenoid is comparison between bar magnet and solenoid is. So bar magnetic field is fixed, but solenoid magnetic field can be changed by changing the strength of current and number of loops. If number of loops are increased and the strength of current is increased, so the magnetic field will be increased. Here, magnetic field we can't increase. Magnetic field we cannot change. Magnetic field is fixed. Okay, but here we can change. Okay, so if you suspend the magnet, bar magnet always shows north and south direction. Here also, if you suspend the solid, it always shows north and south direction. So here, one now. If the current is passing clockwise direction, so if the current is passing clockwise direction, that is south pole. If the current is passing clockwise direction, that is south pole. If the current is passing anti-clockwise direction, that is north pole. So very important. This is a clock phase rule. So clock phase rule, by using clock phase rule, we can identify the poles of the, okay. So poles of the current carrying conductor or current carrying solenoid. Like here. So if the current is passing anti-clockwise, so clockwise direction, first one clockwise direction, second one is anti-clockwise direction. First one is clockwise direction means that is south pole. Next one is anti-clockwise direction is that is north pole. Right? So that's enough. Next, one more concept is left out. That is current carrying conductor placed in the external magnetic field. Current carrying conductor placed in the external magnetic field experience the force. Experience the force that I will discuss. Then if you know that, okay, last one if I discuss that concept, then this chapter is completed. That is magnetic effects of electric current. Okay, done. Carry on. Now, current carrying conductor placed in the external magnetic field experience force. So current is passing downward direction like this. The current carrying conductor placed in the external magnetic field, right? So this is the current carrying conductor placed in the external magnetic field, north pole, south pole. So by using Fleming's left-hand rule, we can identify the force acting on the conductor. By using Fleming's left-hand rule, we can identify the force acting on the current carrying conductor. So thumb represents, so thumb leave it, main thumb only. So index finger represent the magnetic field, middle finger represent the current, and thumb represent the force acting on the conductor. So index finger, middle finger, and coming to the thumb finger. So index finger represent the magnetic field, middle finger represent the current direction, and thumb finger represent the force acting on the conductor. Okay, so if you place like this, then so the conductor will move inside or into the board. So this is about current carrying conductor placed in the external magnetic field experience the force. I hope it is very clear to you all. Okay, so this is about magnetic effects of electric current. So be very clear with that. So thank you so much for joining and attending and listening the class. If you have any doubts, you can ask. So my Instagram ID is given to you. Okay, so it is there in the description. description below. If you like it, you can share and follow my Instagram page, and you can do like, share, and subscribe to my channel, Student the Brand. So thank you so much for attending and listening and joining to the class. This is Evar Siva sir from Student the Brand. Okay, so if you have any queries, any doubts, you can follow the Instagram page and you can contact to me through Instagram page. And one more thing, so I'm conducting the test series assessments related to whatever topics I'm explaining. So on that, I'm conducting the test series. So follow the community post, check my community post. Okay, so check in the community post. So check the student the brand community post. Then in that every day I'm posting the messages related to test and related for grade 11 and grade 12 students also. I'm uploading the MCQs. I'm posting the okay MCQs in the community post. Check once and attempt those MCQs. Okay, and if you like the content, if you like my channel, if you like my explanation, so please do like, share, and subscribe to Student the Brand. This is your Sir from Student the Brand. Thank you so much for joining and attending, listening.